in this example. So let us now try to see the application of z-distribution or the advantage of standardizing the data. I've already shown you the GMAT score, and suppose the GMAT scores can be modeled reasonably using a normal distribution with mean mu 711 and standard deviation sigma, which is 29. I've also calculated this. Mean for GMAT is 711. In standard deviation for the GMAT is 29, right? Roughly 711 and 29. Now, what is the probability that if you pick a student randomly, the student's GMAT score is going to be less than or equal to 680? This is what we need to calculate now. And where would you find the mean here? Mean is always the peak, right? So do you see a peak there? That is your mean, which is 711. And where would we find 680? Would it be towards the right of the mean or left of the mean? It would be towards the left of the mean, and 780 would be roughly here. Or sorry, 680, my bad. Be roughly there. Now you need to calculate the probability of randomly picking a student, and the student's GMAT score happens to be less than or equal to 680. So I'm speaking about, do I have a white color? No. Okay. I'm speaking about this region. Right? So if I can standardize this value, right, I can use a standard table to calculate the probability. What am I saying? Whatever be the value, whatever be the random variable, it can be GMAT score, it can be work experience, it can be any other value absolutely. Whatever be the value, if you can standardize the value, you can use a standard table to calculate the probability, right? So let me do this. Let me write the formula for standardizing. X minus mu upon sigma. X is 680 here. So it is 680 minus mean is 711 divided by standard deviation, which is 29. If you do this calculation, you'll get minus 1.06. Now this is the standardized value. For 680 or for 680, this GMAT score, the corresponding standardized value is minus 1.06. And for this standardized value, I can calculate the probability in three ways. One is I can refer to Z table. Oh. Okay. I think I do not have this open. Let me do that. Z table. Remember your school days, you used to carry a logarithmic book along with you? Yeah, I'm taking you guys back to your school days. Not even to your college days. I'm taking you guys back to your school days. Then we have learned it for marks. Now we are learning it for career. Okay. Here is the Z value. In Z value for which we need to calculate the probability is a minus 1.06. And what is minus 1.06? This is a standardized value for your GMAT score 680. Minus 1.06 is here. Minus 1.0. Minus 1.0 is here. So I need to also look into 0.06. 0.06 is here. So if I traverse in this direction, and if I traverse in this direction, Here is the intersection. So this is the value corresponding to minus 1.06. So this is how you arrive at your probability value. Alright, this is one way of calculating, right? Most often than not, in real world, you'll not refer to this table. I'm showing you all this just to explain you all that it can be calculated even using a z-table. But in real world, you'll bank on your statistical tool, in this scenario R. So if you do a p-norm, probability of normal distribution, p-norm, probability of normal distribution. And here you can say 680, 711, 29. The formula or the function is written in such a way that you have x, mu, and standard deviation. So let me write it here. The function for p-norm is p-norm of x, mean, standard deviation. If you're confused with what arguments have to be written within these braces, you can always use a question mark. I'll show you in a moment. I enter. I click on enter and I get 14%. That is your probability, roughly 14%. Roughly it is 14%. Yep. Now, if you want to know the arguments properly, you can do a question mark and type p-norm. And you see here for p-norm it's q, mean, standard deviation. This is for your standard normal distribution. But since we are calculating it for some other value, it is 680, 711, and 29. Internally, it does that calculation. It standardizes the data and calculates it. All right. And another way of calculating is using your Excel sheet. In your Excel, the formula is simple. It is normal distribution. Oh, my bad. It is normal distribution of, it's given here, x, mean, standard deviation, and cumulative, right? X is 680, mean is 711, standard deviation is 29. Since it is continuous data, cumulative is 1. Yep. So you get a probability of, once again, 14%. All right. To make your understanding even clear, I would do another problem. All right. So let me choose here. Yep. What is the probability that if I choose a student randomly, the student's GMAT score happens to be within this range of 697 and 740, right? So 740 would be somewhere here and 697 would be somewhere here. So what is the probability that if I choose a student randomly, the student's GMAT score happens to be within this range? This is what we need to solve. As I've told you, if we can standardize the values, here we have 740, the first value. So if you can standardize this value, you can refer to the standard table or you can calculate the probability in a standard way. So how do I standardize 740? Z is equal to x minus mu upon sigma. X is 740, so it is 740 minus. Mean is given to us as 711. Standard deviation is given to us as 29. If I solve this, you would get 1. Z equal to 1, right? Now, for Z equal to 1, if you want to calculate the corresponding probability value, either you can go to the Z table and try to calculate. Let me show you that. So here you have the Z values and here you have 1. So the Z value corresponding to 1 is 0.8413. And that is what is given here, 0.84. At the same time, you might also want to calculate the probability. Now what this has done is the probability value for 740 would actually calculate the complete region towards the left. By default, that is how it calculates. Complete region towards the left. Fine. Now, if you want to calculate the probability of the value being greater than 697, yeah, this can be written as x value greater than or equal to 697 in x value less than or equal to 740. Right. Now less than or equal to 740, you have solved it. By default, you get the probability value towards the complete left of this. Now if you want greater than or equal to 697, then 697 would be roughly here. Then what we need to do is, we need to calculate the z value first. Z is given as x minus mu upon sigma. And x value here is 697. Minus average is 711. Standard deviation is 29. These two values are given to us. If I solve this, I would get minus 0.5. And you can go to the z table, right, and quickly calculate for minus 0.5 and for minus 0.5 z value, it happens to be roughly 0.31. If you round it off, it is 0.31, and that is a value which is given here. But as we've already discussed, whenever we calculate using that standard table in a standard way, it will calculate the probability towards the left of 697, complete region towards the left. And when we have calculated it for 740, it has calculated the complete region towards the left once again. This region, complete left. However, the area of interest for us is this region. It is this region, and this region is this one. X value greater than or equal to 697 and x value less than or equal to 740. So you want this region basically. And if you want this region, all you can do is calculate the probability for 740, which will calculate the complete region towards the left, and subtract the probability of 697 from that complete region. The leftover region would be this yellow color region, which is your area of interest. Hence, we are subtracting 0.84 from this to get 0.53. This is how your standard normal distribution or the z distribution will help you calculate the probability values using a standard technique. If you want to calculate for 740 and 697 using R, it is the simple formula once again. So it is P norm of 740, 711, 29. 799 and 29 is already given to you all. Minus, I can directly do it in this way, P norm of 697, 711, 29. You get 0.52, and that is exactly 526, which can be rounded off to 0.53, and you get that roughly.